Hello class, welcome to another video for this course. In this video, we are going to study section 2.4, in which we are going to focus on derivative of trig functions. So far, we learned about sine and cosine function. So maybe let me quickly review what we have learned about derivative of sine and cosine functions. So we know that for sine, the derivative of sine is, so if, let's say, if your function is sine of x, then the derivative is cosine of x. So for function sine, we know that its derivative, maybe I write this here, its derivative is cosine of x. And another trig function that we studied was cosine. And we saw that the derivative of cosine is negative sine of x, okay? But we have more trig functions. If you remember from pre-calc, we also learned about tangent, cotangent, secant, cosecant. So we have more trig functions. So in this section, we want to see what is the derivative of those functions and do a couple of examples. But the point is that since these functions, sine and cosine are very basic, but then tangent, cotangent, secant, cosecant, we can derive them from sine and cosine. So for that reason, we are going to derive their derivative as well. So a quick refresher about unit circle and trig in general. So in this picture, you see the unit circle. It's a circle which is centered at origin with radius 1, and any point on this circle correspond to a unique angle. For that reason, any point on the unit circle can be expressed as a function of the corresponding angle. And you have learned that this right triangle, this green right triangle, can give us the sine and cosine. So this is theta, right? And then we can derive the sine and cosine. Actually, the value of the sine and cosine correspond to the size of these two sides of the triangle. So this is not new. I just wanted to refresh your mind about unit circle, and also we learned about trig identity in pre-calc. For example, the fundamental trig identity is that sine square plus cosine square is 1, which is obvious from this right triangle, because we know that here this side is 1, this side is sine, this side is cosine, and we know that the relationship between we know that there is a relationship between three sides of a right triangle, which is expressed here. So this is a fundamental trig identity. And now we also, let me quickly refresh your mind. Tangent. What was tangent function? It's the quotient of sine and cosine. So sine divided by cosine. Cotangent is just inverse, flip the fraction. So cotangent is the division of cosine by sine. Secant is the inverse of, not inverse, it's the reciprocal of the cosine. So it's 1 over cosine. And finally, cosecant is a reciprocal of sine function. So 1 over sine. Okay, so actually that's enough. Yeah, I mean, you don't need to know more than this, and you already know this stuff. So this is just a refresher from pre-calc. If you just remember the definition of tangent, cotangent, secant, and cosecant, and also remember, for example, this trig identity, then we are good. We can derive the derivative of each one of them. For example, tangent. I'm going to show you how to derive the derivative of tangent. For example, look at the function of tangent of x, right? So the question is, okay, what is the derivative of tangent? As a function, this has a derivative. So what's that derivative? So let's recall the definition of tangent is sine over cosine, right? Okay, so we know the derivative of sine, it's right here. We know the derivative of sine and we know the derivative of cosine. And here I have their division. We also learned about quotient rule. So just we can apply the quotient rule. So what was the quotient rule? Do you remember? The quotient rule says that, imagine this is a function in the numerator and this is a function in denominator. Do you remember? So the derivative is gonna be denominator times derivative of numerator minus numerator times derivative of denominator, denominator square. Do you remember quotient rule? So I'm gonna apply the quotient rule here, okay? So I'm just gonna write, this is gonna be the derivative. So derivative of tangent, okay? Derivative of tangent is gonna be denominator, which is cosine, times derivative of numerator minus numerator times derivative of denominator over denominator square. Okay, so far I have done nothing except just rewriting the quotient formula. In the next step, we can take the derivative. So for example, we need to take the derivative of sine. Derivative of sine is cosine. Derivative of sine is cosine. We need to take the derivative of cosine. Derivative of cosine is negative sine. That's it. So we are done with derivatives. So just to make it clear here, right? Derivative of sine is right here and derivative of cosine is right here. Okay. So then the rest is just simplifying. Let's simplify this term. So this is going to be cosine square. This is going to be negative times negative positive, sine times sine square over cosine square. Okay, now apply the trig identity, the fundamental trig identity. So we know that cosine square plus sine square is 1. Trig identity. This is the fundamental trig identity. Remember? So this is gonna be 1. So numerator is 1, denominator is cosine square. So that's it. You can say derivative of tangent is cosine square. Therefore, what is the derivative of tangent? Derivative of tangent is 1 over cosine square. You can say that. You can also, by the way, that's enough. But by the way, you can express it in terms of other function as well, because we know that, please observe that this is the same as 1 over cosine square. So what is 1 over cosine? That's just secant, right? So instead of 1 over cosine, you can say secant. So this is secant square. So alternatively, you can say that derivative of tangent is secant. There are same thing, secant square. So you can either say secant square or 1 over cosine square because they are the same thing. But often in the textbook, it says secant square. So I think it would be wiser if we go with secant square. We denote it with the secant version rather than cosine version, but they are definitely the same thing. So this is the big picture, okay? How did I derive? So look, we derive the derivative of tangent. How? we just apply the quotient rule because it's the division of tangent is the division of sine and cosine. So we first apply the quotient rule, and then in the middle of the work, I use the trig identity, this trig identity. Sine square plus cosine square is 1. This is the fundamental trig identity to simplify it. And then that's it. So the derivative of tangent is secant square. Okay. Now, and you have, by the way, you have it right here as well. So for tangent function, the derivative, so the textbook use this notation for derivative, d over dx, differentiate tangent of x. It's gonna be secant square. Now let's find it for cotangent. Okay, let's do the same thing. By similar idea, you can find the cotangent, but I can show you. It's pretty straightforward, but I can show you. So now let's drive the derivative of cotangent. What is the derivative of cotangent of x? What is the derivative of cotangent of x? Again, recall that cotangent is the division of cosine by sine, right? Cosine divided by sine. That's just the definition of cotangent. Again, because this is division, so we can apply the quotient rule, right? So in this step, I'm gonna apply to take the derivative. So look, we need to take the derivative of cotangent, right? So that means we need to take the derivative of this quotient, of this fraction. So we know that we can, whenever you have this, you can apply quotient rule. Okay, so just apply the quotient rule. So it's gonna be what? Denominator times derivative of numerator minus numerator times derivative of the denominator over denominator square. Okay. The next step is just take these derivatives. So I need to calculate the derivative of cosine, which is negative sine. And I also need to calculate the derivative of sine, which is cosine, over sine square. So here, okay, the derivative of cosine is negative sine, and the derivative of sine is cosine. Okay, the next step is just simplify them. Let's see if we can group them or simplify them. So this is gonna be sine square, negative sine square, and this is gonna be negative cosine square over sine square. Now, again, look, numerator, we can factor out the negative sign from the numerator, sine square plus cosine square. And then we can apply the trig identity, the fundamental trig identity that sine square plus cosine square is always equal 1. So this is gonna be negative 1 over sine square. That's it. So you can say that derivative of cotangent, the derivative of cotangent is, that's it. Derivative of cotangent is negative 1 over sine square. I can put that here. So the answer is negative 1 over sine square. Okay, you can say this is the answer. The question is, what is the derivative of cotangent? We did this, we applied this rule, the trig identity, and this calculation, and we derive negative 1 over sine square. So this is when you want to express the derivative in terms of sine function. But this can be represented in another format as well, because look, it's negative 1. It's negative, we can rewrite it as negative 1 over sine of x square, right? So what is 1 over sine? That's cosecant. So it's negative cosecant square. So that's up to you. I mean, that depends on the question. Sometimes we say, I mean, depends on what's the application. Sometimes you may say, okay, I'm like to use the sine format to say the derivative of cotangent is negative 1 over sine square, but sometimes it's easier, it's more applicable to say that the derivative of cotangent is negative cosecant square. But both of them are the same thing, okay? So they are same thing. So what is the derivative of cotangent? Is negative cosecant square. So, and you can also find that summary here, that the derivative of cotangent is negative cosecant square. This is often the format that we use. So there we go. We found the derivative of tangent and cotangent. Maybe I put a table as a summary of what we already know. So let's do a summary. So on this column, I'm gonna put the function, and in this column, I'm gonna put the derivative. So let's say here you have function f. So you have function f of x, and in here you have the derivative. Its derivative f prime of x. So this is gonna be the derivative function. Okay, so what we have learned from past, we know that when the function is sine, the derivative is cosine. We know that when the function is cosine, derivative is negative sine. What we have learned today, we learned that if the function is tangent, derivative is secant square, right? Look, we just learned it here. If the function is tangent, derivative is secant square. And we also learned that if the function is cotangent, then the derivative is negative cosecant square. Okay, so far we learned about the derivative of 4 trig functions. Okay, look, if you want, by the similar idea, you can derive the derivative of secant and cosecant. I may show you, let me show you secant. Let me derive for you the derivative of secant. So the next step is, the question is, what is the derivative for secant? So when you have the function of secant, what is its derivative? So let's derive a formula for the derivative of secant. So secant. So the question is, for secant of x, what is the derivative, right? So what is secant? Do you remember? Secant is 1 over cosine of x. And if you forget, you can also refresh your mind either here or on top of the page. I think it's right here, that the secant function is just the reciprocal of cosine function, which means that secant is 1 over cosine. Okay, now we are looking for the derivative of secant, so we can take the derivative of 1 over cosine, because we know what is the derivative of cosine, and we know the quotient rule. So we can use quotient rule. We can use the quotient rule in order to compute this derivative. So it's gonna be derivative, it's gonna be denominator times the derivative of numerator. Derivative of 1 is 0 minus numerator times derivative of denominator. Derivative of cosine is negative sine over denominator square. So here I did two things at the same time. I applied the quotient rule and I also took the derivative. So in my head, I said, okay, derivative of numerator is 0, derivative of cosine is negative sign. Okay, now let's simplify. 0 times anything is 0. So this is gonna be 0 minus, so negative times negative is positive, 1 times sine is sine over cosine square, over cosine square. So that's it. You can either leave your answer like this, or if you want, you can simplify. Let's see how we can further simplify this to express it in other terms. For example, look, this is sine. Denominator is cosine square. So it's cosine square is cosine times cosine, right? Now I can express it in another terms. Look, because sine divided by cosine is tangent. And then here it's like you have 1 over cosine, right? 1 over cosine is secant. So oftentimes we go with this format, that derivative of secant is tangent times secant, secant times tangent. So that's the answer, secant times tangent. Secant, so the derivative of secant is secant times tangent. Okay, you see? Pretty straightforward. So again, because these functions, tangent, cotangent, secant, cosecant, are defined by sine and cosine, we can just apply the rules, the identities that we have learned in order to calculate and drive the formula for these derivatives. So that's about secant. So let me add it to the table. So derivative of secant is secant times tangent. The last one is cosecant. Let's calculate the last one to complete the table. So for cosecant, again, what is the definition of cosecant? So we are looking for the derivative of cosecant. We want to find the derivative of cosecant. What is cosecant of x? It's reciprocal of sine. So it's 1 over sine of x, right? 1 over sine. And so if you want to take the derivative of cosecant, take the derivative of 1 over sine, because you already know the quotient rule, right? Apply the quotient rule and just calculate this derivative. 1 over sine. So you have numerator, denominator. So quotient rule says that multiply it on top, put denominator times derivative of numerator. What is the derivative of 1? It's 0. Minus numerator times derivative of denominator. What is derivative of sine? Cosine. Over denominator square. So this is gonna be 0. So it's gonna be negative cosine over sine square. That's it. Now, you can express it in other forms. Look, in other format. Look, this is negative. This is cosine over sine square. So sine square is sine times sine, right? So now look, cosine over sine is cotangent, right? And reciprocal of sine, like 1 over sine. You see that there is a 1 over sine here. You can express it as secant, as cosecant. So that's it. So oftentimes we say that the derivative of cosecant is negative cosecant times cotangent. So I'm going to put that here. So we derived this derivative. The derivative of cosecant is negative cosecant times cotangent of x. So if I add this last one to the table, we will be done. Look, the last function was cosecant. So cosecant of x. And we observe that its derivative is negative cosecant of x times cotangent of x. That's it. So these are the basic trig functions. So on the left column, look, on the left column, you see 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant. On the right column, you are seeing the derivative. Okay, so from previous sections, you learned that the derivative of sine is cosine. The derivative of cosine is negative sine. Today, in this video, you saw that derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant times cotangent. Since we are going to use them in problems, in calculations, I think it would be wise if we keep these derivative in mind. Otherwise, every time we have to go through all these steps to find the derivative. So I recommend you to I'm not saying memorize it. I would say keep using them in problem until they stick in your mind. Okay, now let's do one problem to actually use this. For example, let's look at this problem, this activity. So in part A, a function is given. Okay, and the question is find the slope of tangent line to this function at this given point. Okay, so let's do this. Okay. So the question is, so first of all, this is activity 4 of this section, and part A, the function is 5 secant minus 2 cosecant. 5 secant of x minus 2 cosecant of x. So this is the function. The question is find the slope of tangent line to the function at this given point. So this is not new. We know that tangent line, the slope of tangent line to the function at a given point is the same as derivative of that function at that point. But I'm going to write this down to refresh your mind. So the question asks us to find the slope of tangent line to f at what point? Pi over 3. So this is this whole thing, the slope of tangent line at pi over 3 is the derivative of the function at pi over 3. So basically, we just need to find the derivative of the function and then evaluate it at pi over 3, okay? So whenever the question asks you to find the slope of tangent line at a given point, just take the derivative of the function and evaluate it. So first, so here are the steps. First, find derivative of x. Second, evaluate f prime of pi over 3. So we need to do these 2 steps. The first step is to just take the derivative. Okay, let's calculate the derivative of f. Okay, derivative of f. So since f, so let's do 1. F of x is 5 secant of x minus 2 cosecant. 2 cosecant of x, and we are looking for the derivative of f. 5 is multiplier, so I'm going to just carry that. We need to take the derivative of secant. So recall that derivative of secant, I'm going to use another color, is secant times tangent. Do you remember? We just observed that. Minus 2 times. Now we need to take the derivative of cosecant. So recall that the derivative of cosecant was negative cosecant times cotangent. Okay, so here I take the derivative of secant, and here I put the derivative of cosecant. Okay, so that's gonna be, let's simplify it. 5 secant of x times tangent of x, negative times negative, positive 2 cosecant of x times cotangent. If you want, you can simplify further, but I'm gonna leave it like this. I mean, there's no point to simplify it further. That's the derivative. Okay, now let's do the second step. What was the second step? The second step was to evaluate f prime at pi over 3, right? The second step was to evaluate f prime at pi over 3. So just substitute this value for x, secant of pi over 3, tangent of pi over 3, plus 2 times cosecant of pi over 3 times cotangent of pi over 3. So that's it. We need to evaluate these. Okay, so you can use calculator, or if you can use calculator, or if you know the values on top of your head, you can just substitute those. So if you want to use calculator, for example, if you go to GeoGebra and go to scientific calculator, so the first thing we need is secant of pi over 3. So it's gonna be secant of pi over 3, which is 2. Yes. So this is 2. So this is 2. And what is tangent of pi over 3? I believe you have it on mind, but if you don't, it's fine. Tangent of pi over 3. Okay, so no, I don't want it in this format. I want it in terms of, in another term. I want it in 2e. I don't want it in the exact, I want it in the exact value format. That gives me the decimal format. So if you remember, I'm gonna show you the calculation. So if you remember tangent, if you don't remember it, tangent of pi over 3, what was the definition? Is sine over cosine, right? So since sine is square root of 3 over 2, and this is 1 over 2, so it's gonna be a square root of 3. That's the format I wanted to substitute here. So you know what I mean? The exact value of tangent of pi over 3 is the square root of 3. The value that you see here is the same as the square root of 3. Look, if you put the square root of 3, it's also 1.73, blah, blah, blah. But I didn't want to use this decimal format. I wanted to substitute the exact format. And cosecant, let's calculate cosecant now. Cosecant of pi over 3, pi over 3. Okay, I don't want this as well. I want let me see. So cotangent is just the inverse of so this is gonna be 1 over square root of 3, or a square root of 3 over 3, and I can calculate cosecant as well if we want to have it in exact format. Because what is cosecant? I'm going to use another color so you can follow. Cosecant is 1 over cosecant is 1 over sine, right? And we know that sine is a square root of 3 over 2. So you just need to flip it. So you can say, so it's going to be 2 over a square root of 3. Let me keep that in this way because it's actually good. We can simplify that, okay? I wanted to use them in this format. So it's going to be, look, 5 times 2 is 10, the square root of 3. Then we have, look, we have 2 over a square root of 3. Or maybe I don't multiply them at the same time. Let me just copy the calculation. So it's 5 times 2 times the square root of 3 plus 2 times 2 over the square root of 3 times the square root of 3 over 3. Now, this is going to be 10 square root of 3, and this is going to be, we can cross these two, 4 over 3. But yes, if you want eventually, I mean, it depends on the question. Sometimes, if the question doesn't ask you to how to enter your answer, then you can leave your answer in either in decimal or in the exact format. So if the question asks you to enter your answer in the exact format, so you enter 10 square root of 3 plus 4 over 3. But if the question asks you to enter in decimal, then you need to, round it to whatever number of decimal the question asks. But the point here is not that. The point here is taking derivative of such function. So here is the big picture. You have this function. What is the function? 5 secant minus 2 cosecant. We ended up by a need to find the derivative of this function. So we just used what we learned, that for secant, this is the derivative. For cosecant, this is the derivative. And we just apply them, and then finally we do it our calculation. So I recommend you to do the rest of these problems. They are pretty straightforward. You just need to practice taking derivative, and you can definitely use this table as a summary of derivative for trig functions that we have learned so far. Yeah, so here is also a good summary, by the way. Yes, you in your textbook, you have a summary of what we learned in this section. Derivative of tangent is secant square. Derivative of cotangent is negative cosecant square. Derivative of secant is secant times tangent. Derivative of cosecant is negative cosecant times cotangent. So this is exactly what we learned today. We learned the derivative of 4 trig functions. Now you can do any problem, you can do the exercises here. I strongly recommend you to do these exercises to just practice these rules for derivative. And these are very good activities because you can try it and then you can check your answer, you can look at the solution, and even find a step-by-step calculation. So I definitely encourage you guys to do the exercises of this section. That's all for now. Thank you for watching in this video. I'll see you in the next one.